Welcome to another video in our Coding with Arduino for Young Innovators. In the previous class, we introduced Arduino and coding. In this class, we are going to look at the various electronic components we will use to build our first project. By the end of this class, you should be able to explain what a circuit is, understand the difference between open circuit and closed circuit, identify a battery and explain its work, understand how a breadboard is arranged and connected, explain what jumper wires do, identify the positive and negative legs of a light emitting diode, explain what a resistor does, explain how a switch works. And after learning all this, you will be ready to build your first circuit in our next class. So let's get started. What exactly is electricity? Electricity is a form of energy that can move from one place to another. You cannot normally see electricity with your eyes, but you can see what it does. For example, when a bulb lights up, when a fan spins, when a television turns on, when you charge a phone, electricity is helping those things work. Imagine water flowing inside pipes. Water moves from one place to another inside pipes. Electricity behaves in a similar way, but instead of pipes, electricity moves through wires. Electricity has one important rule. It needs a complete path to flow. If there is a broken path, electricity does not flow. That complete path is called a closed circuit, and the broken path which does not allow electricity to flow is called an open circuit. This is a battery. This battery supplies electricity to our projects. A battery supplies energy to our projects to make them work. Without this energy, our projects will never come to life. You can think of it as food for electronics. Notice that it has two terminals or heads. Here we have the positive terminal, and here we have the negative terminal. Electricity leaves the positive terminal and returns through the negative terminal. This component is called a breadboard. And no, we don't eat bread on it. In electronics, a breadboard helps us build circuits easily. At first, it looks like many tiny holes, as you can see here. But hidden underneath are metal connections. Without a breadboard, we may need to twist the legs of our components when we connect them. But with the help of these metal connections of the breadboard, we can connect the legs of our components without damaging them. On this type of breadboard, all the holes from here to here are connected, and then we have a gap here, and all the holes from here to here are connected. The same thing is what we have on this line and this line. However, the holes on this line, that is this first line, are not connected to the holes on this second line. But the holes from here up to this point are connected, and here we have a gap. And then the holes on this line are connected up to this line. And what we have on this first line is also what we have on this second line. But there's no connection between this line, that is the first line, and the second line. Remember that we have a gap here separating these two lines from these two lines. For this side, the holes are connected vertically. So we have connection from this line to this point, from this line to this point, from this line to this point. But we don't have connection from this line to this line, or from this line to this line. That is, the holes on this side are connected vertically. They are not connected horizontally. Now you can see that we have a demarcation here. So this demarcation separates what we have on this side from what we have on this side. And what we have on this side is exactly what we have on this side. So this is how a breadboard is arranged and connected. To demonstrate what I just said, let's make some connections. If I want to connect one leg of each of these two components, here I have two components. If I want to connect one leg of each of these two components together, instead of twisting them, I can fix the leg of one component in this hole, like this, and fix the leg of the other in this hole. So because we have continuity on this line, the two legs are now connected. I can do the same thing on this line, this line, this line, this line, up to this point. I can also do the same thing on these lines or on these lines. As long as you have continuity on any line, you can use it to connect the legs of your electronic components together without twisting the legs of the components. These are jumper wires. Jumper wires are like roads. They help electricity move from one component to another. Here we have three different types of jumper wires. The male-to-male jumper wire. This is the male-to-male jumper wire. You can see the pin. And then we have the male-to-female jumper wire, and then the female-to-female jumper wire. Let's say you want to connect one leg of each of these two components that are far from each other. You can use a male-to-male jumper wire to make the connection with ease by connecting one pin of the jumper wire here and the other pin of the jumper wire here. By doing this now, you have connected this leg of this component to this leg of this component. By connecting one pin of the jumper wire here and the other pin here, the legs of the two components are now connected together. This is a light emitting diode, which is abbreviated as LED. It is simply a device that turns on and glows light when electricity flows through it. An LED has two legs. The longer leg is called the positive leg, and the shorter leg is called the negative leg. As you can see, this is the longer leg and this is the shorter leg. So this is the positive leg and this is the negative leg. The LED comes in different colors. As you can see here, we have different colors of the LED. LEDs are special because they allow electricity to flow through them only in one direction. That is, from the positive leg to the negative leg, and not from the negative leg to the positive leg. We shall learn more about that when we start building our project. This is a resistor. Its work in a circuit is to slow down electricity flow so that it will not damage other components in the circuit. Imagine a playground slide with children sliding too fast. A teacher might slow them down so nobody gets hurt. That is exactly what a resistor does in a circuit. Because a resistor resists electricity, we say that a resistor has resistance. Without a resistor, too much electricity can damage our LED, and that is what we don't want to happen with our projects. Resistors come in different values. The higher the resistance of a resistor, the more electricity it will resist in a circuit. When we tell the value of a resistor, we attach a unit to the value to make everyone understand that it is the resistance of a resistor that we are talking about. The same way we attach dollars or naira or pounds to money so that everyone will know exactly the currency we are talking about. The unit of resistance is ohms, and it can be represented with a symbol called omega. This is a switch. A switch helps us to create open circuits or closed circuits. When a switch is closed, it means that it has closed all the openings in the circuit. Hence, electricity can now go around the circuit through the wires that will make our circuit turn on. But if the switch is open, it means it has created an opening somewhere in the circuit. Hence, electricity, which was supposed to pass through the wire, will no longer pass through. That way, our circuit turns off. Because we use a switch to turn on and turn off our circuits, we say things like switch on and switch off. Basically, what is inside a switch is wires. When a switch is turned on, the wires join together, and when the switch is turned off, the wires separate from each other, breaking the circuit so that electricity can no longer flow. Alright, so far in this class, we have discussed the various components that we will use to build our first project. We discussed batteries which supply energy to our circuits. We discussed breadboards which help us connect components easily. We discussed jumper wires which help electricity travel from one place to another. We discussed the light emitting diode, abbreviated as LED, which glows when electricity flows through it. We discussed resistors, which protect our components by slowing down electricity. And finally, we discussed switches, which help us turn our circuits on and off. Remember, every big invention starts with understanding the small things that make it work. Now that we know our components and understand what they do, we are ready for something even more exciting. In our next class, we will put all these components together and build our very first project. I am Instructor Izu, and I will see you in the next class. Bye.